To understand how it is affect us, we first need to understand what this process is. Nuclear fission is a reaction which requires radioactive elements such as uranium or plutonium. It is the splitting apart of the atom nuclei into two smaller nuclei. In this process, a great amount of energy is released, and this is what we are after. Only a few types of nuclei such as uranium-235 and plutonium-239 can withstand a chain reaction. This is due to the fact that these nuclei release neutrons which collide with other nuclei, resulting in them also breaking apart and releasing more neutrons. The most common fuel used in nuclear power plants is the uranium-235, as it is in more abundance than the plutonium, and the chain reaction factor is very useful in this controlled process of radioactive decay. Thus, once this chain reaction is activated, the energy created is used to boil water and spin the turbine in an attempt to generate electricity. The chain reaction is controlled by the control rods, which can slow down or completely stop the reaction, as they contain materials with the ability to absorb neutrons. Now that we have a sort of basic understanding of this process, let's talk about why we humans research this in the first place. We all require energy in our lives, maybe for our smartphones, televisions, etc., or for our cars and planes for transport. Basically, our current generation would be lost without this. However, we have been burning fossil fuels to get this energy. Fossil fuels are a non-renewable source of energy and will most likely run out within the next 50 years, which is why we need to research new forms of energy generation. Renewable sources of energy such as solar, wind, and hydroelectric seem to be the best choices for energy generation due to them being unlimited sources. However, they are not the most dependable as they are weather-based. This doesn't work if there isn't enough sunlight or water or wind. This is where nuclear fission comes into fruition. With renewable sources of energy being undependable and the threat of fossil fuels running out amplifying, another source of energy needed to be researched, which was why nuclear fission was created. This process may not be renewable, however, little mass of uranium, which is an abundant source, is required to produce large amounts of energy. Since we have understood the problem nuclear fission is being used to solve, let's talk about the physics behind the operation. Basically, what needs to be explained is that small particles called neutrons are in motion and are what start this reaction. The main idea of this is that when the neutron comes close enough to the uranium-235, the nucleus's force pulls it, the neutron becomes captured, and this usually leads to the fission process. What the process of nuclear fission does is takes a small mass of a radioactive material and bombards it with neutrons to start the fission process. Ever heard of Einstein's famous equation E is equal to mc squared? Well, it's applied here as E is energy, m is mass, and c is the speed of light, roughly 300 million meters per second. So what happens is, even though a small mass of the nucleus is used, large amounts of energy is released as c is quite a high number. For example, 1 kilogram of this kind of matter would produce the amount shown. This amount of energy is usually obtained by burning 3 million metric tons of coal. The reason this energy isn't released by the coal reaction is due to the fact that this reaction releases the nucleus's energy, which is far more powerful than breaking the intramolecular forces between the molecules/atoms. To understand why so much energy is released, we need to talk about another concept, the binding energy in the atom. This is the energy required to completely break up the nucleus. Elements in the middle of the periodic table with intermediate mass numbers have a higher binding energy for the nucleon, which is the neutron or proton, meaning there is a lower atomic weight per nucleon. When the heavier weights, such as heavier atoms such as uranium, are blasted by neutrons, the products formed are of the intermediate atomic weight. This can be explained easier mathematically. For example, if the total binding energy of the heavy nucleus on the two fission products be V1, V2, and V3 respectively as shown. Let's talk about the development of this technology. 75 years ago, three researchers, Dr. Otto Hahn, Dr. Lisa Meitner, and Dr. Fritz Strassmann, working at the Kaiser Wilhelm Institute for Chemistry in Berlin, built up a trial grounded on the then developing idea that splitting an atom of an element would create two particles of littler, diverse elements. As uranium was exposed to the neutron source, which was a mix of radium and beryllium, the fission process occurred. Their hypothesis of the experiment was based on the assumption that the atom would split in the same way that a water droplet does, and this matched the theory published by Niels Bohr at the time. They authored their newfound methodology, nuclear fission, as it was equal to the fission saw in biology cell division. This earned Otto Hahn the Nobel Prize for Chemistry in 1944. The discovery of nuclear fission has had a huge impact on humanity in terms of the economy. For starters, nuclear power is cost competitive to other forms of energy generation, electricity generation, except the low-cost fossil fuel. However, nuclear power is more environmentally friendly and is in more abundance than fossil fuels. This is one of the few economic advantages. There are many disadvantages, such as the fact that the fuel costs are low. Although the fuel costs are low, the capital costs, generating costs, etc. are a lot higher than the coal-fired plants. Also, the decommissioning and waste disposal costs are taken into account, which amount to quite a lot. Looking at the relative costs of the new generating plants, which use different complex technologies, is a difficult matter, and these results depend mainly on the location. Areas such as China and US will be dependent on coal being the main source of energy for a long period of time, at least until other forms such as nuclear become improved upon and fall in prices. These plants, although require higher amounts of capital costs, are actually quite cheap to run and so in the long run start providing for itself. In conclusion, the development of the process nuclear fission was very effective in solving the problems of generating power. However, there are very many economic setbacks due to the increased capital costs compared to the fossil fuel power plants. Though they are cheaper to run, governments aren't willing to fully let go of fossil fuels and therefore are still highly dependent on fossil fuels. Thanks for watching this video to the end.